In this video we're going to talk about exponential expressions. So we know already that if you wanted to add the number 2 to itself 3 times, well, we know that there's a shorthand notation for that. When somebody writes 2 times 3, one way to look at it is that represents 2 added to itself 3 times. So rather than write out 2 plus 2 plus 2, we just write 2 times 3. And of course 2 times 3 is equal to 6. Now the question is, do we have a similar notation when instead of addition we have multiplication? So for example, if you have 2 multiplied by 2 multiplied by 2, do we have a notation for that? And the answer is yes. We create what's called an exponential expression. So what we do is we write the 2 and then we write the 3 raised, if you will. So the number here that's written below, that is the number that's being multiplied by itself, in this case 3 times, that number is called the base. And the number that's up here that represents the number of times, in this case, that you're multiplying 2 by itself, so multiplying 2 by itself 3 times, that number is called the exponent. And the whole thing, everything, is called an exponential expression. So every exponential expression has a base and it also has an exponent. Well, in this case we know that 2 times 2 times 2 is equal to, well, 2 times 2 is 4, and 4 times 2 is 8. So 2 to the third is equal to 8. So if we take another one and we say, okay, what is 3 raised to the second? And that's how we articulate this, by the way. We say the base raised to what we call the exponent or the power. So this would be, I would say this as 3 raised to the second power. Well, this means 3 times 3, and I know that's equal to 9. Now, of course, the base doesn't have to be positive. Instead, what we could do is we could have something like this. We could have, for example, -4 to the second power. This is also, by the way, said -4th squared. When the exponent's a 2, people often say squared. Well, what does this represent? -4 multiplied by -4. And as we know, that's equal to +16. Now, what if somebody wrote, instead of this, if somebody wrote that? Now, this looks very similar to that, but what's missing are the parentheses. And what's the difference? Well, the difference is here, somebody wrote the parentheses to tell you that the negative is part of the base. You see, if the parentheses are left out, that means the base is not -4, but +4. So what this is telling you to do is take 4 and square it and leave the negative on the outside. So the negative stays where it is, and then I square 4 and I get 16. Notice I got something different than I did in the previous example. The reason is because up here the negative was part of the base. -4 times -4. Down here, this was just 4 times 4, and then I put the negative in afterwards. So we could have another example like that. We could have something like this. -2 to the third. And I see that the negative is part of the base because the negative is included in the parentheses. So this is -2 times -2 times -2. And what I now notice is that, well, -2 times -2 is +4, but then I also have this -2 here. And +4 multiplied by -2 is equal to -8. Now, it's also possible that our base has a fraction, or is a fraction. So for example, I could be asked to find Well, 1/2 to the third power. And what does that mean? Well, that tells me take 1/2 and multiply it by itself 3 times. So that's 1/2 times 1/2 times 1/2. And then now I multiply fractions the way we talked about. So because there's no cancellation, we multiply straight across, and I get 1. And then I multiply the denominator straight across, and I get 8. So 1/2 cubed, or 1/2 raised to the third power, is 1/8. Let's take one that combines some of the things we've talked about. What if you had, for example, you were asked to find the negative of negative 2/3 squared? Okay, so when I look at this, the first thing I think to myself is the base is what's in parentheses. The base is negative 2/3, so I'm taking negative 2/3 and then I'm squaring it, and this negative just comes along for the ride. It's not affected by the act of squaring. How do I know that? Because this is not in parentheses. That negative is, but this one is not. So I leave that negative where it is, and then I say to myself, okay, take negative 2/3 and square it. So I get negative 2/3 times negative 2/3. And focusing on the negative 2/3 times a negative 2/3, well, a negative times a negative is a positive, and 2 times 2 is 4, and 3 times 3 is 9. So now I have negative 4/9, which is the same as negative 4/9, where I viewed this like a negative 1, and negative 1 times 4/9 gave negative 4/9. And that's how you deal with exponential expressions.